Hey, what is going on, guys? And welcome back. We are continuing with the uh, Introduction to Programming with Python course material. We finished section 1 under chapter 2 yesterday. We're going to be going on to section 2. But before we do that, I just wanted to do a little bit of housekeeping. And I wanted to show you guys the GitHub repository again. I went ahead and uploaded the remaining exercises from part 1. We were up to, I think, exercise 8 that I had uploaded a few days ago, and then I had a chance to upload the remaining solutions to all the remaining exercises from part 1. And I went ahead and uploaded the first 3 solutions from the first 3 exercises we did for part 2. So those are also up. The rest will be posted here as well. Um, if you do get a chance to go check out the repository, please give it a star. It truly means a lot. Just lets me know that people are following along and they are appreciating the effort of me to uploading these solutions. The solutions go hand in hand with the videos, so if you watch the videos, you'll see the solutions, but if you just want to skim through them and see these solutions ahead of time, you can just come to the repository and take a look. I'll continue updating the repository until we finish the course, and after that, we'll probably move on to another course, or I'll just do one of my own videos talking about other programming topics. So the link to the repository will be in the description of this video. I will also leave links to any other topics that I do talk about briefly while we're reading through the material and doing the exercises, like I did in the previous videos when I covered self-documenting code and different styles when it comes to writing variable names like camel case, Pascal case, capital case, etc. So, when I do stuff like that, I'll leave the links in the description, whether it's a MDN article or another reputable source, a video. You can definitely count on me to leave those links in the description below just to give further notes. So let's continue. So section 2 is a little bit more on conditionals, and the learning objectives are as follows. It says you will know how to create multiple branches with conditional statements within conditional statements. You will understand the purpose of if, elif, and else statements within a conditional statement, and you'll be able to use the modulo operation in Boolean expressions. So the modulo operation is the %. If you have experience programming in other languages like C++ or Java or JavaScript or TypeScript, you will know that conditional statements, if, elif, and else appear, but in those languages they use else if. So if this, do that, then else if, do that, else do the final condition. Do the final set of instructions. So elif is the same thing as else if in other programming languages. All right, let's begin. Let's have a look at a program which asks the user to input a number and then prints out different messages based on whether the number is negative, positive, or equal to 0. So here we have a variable called number. It stores the inputted value, the integer inputted value. Then we have this conditional statement checking if number is less than 0. Then we want to print the number is negative, and if number is greater than or equal to 0, to print the number is positive or 0. This looks a bit clumsy and repetitive. We only ever want to execute one of the if blocks because the input will always be either below 0 or above. That is, either number is less than 0 or number is greater than or equal to 0 is true, but never both at the same time. So the first conditional statement actually contains all we need here. If it is true, the number is negative. If it is false, the number equals 0 or is positive. Instead of creating another conditional statement, as in the example above, it is possible to create another branch of the same conditional statement to cover all cases where the condition was false. This is called the else statement. The previous example, rewritten. So again, we have a variable here called number. It stores an integer. Then we ask if number is less than 0, print the number is negative. Else, it's the same thing as saying like otherwise, that if you're speaking in natural language, it's like saying if this number is less than 0, then do this, print the number is negative. Otherwise, print that the number is positive or 0. When using an if-else construction, one and exactly one of the branches will always be executed. So either this happens or this happens, but never both. The following picture illustrates the structure. So here we have a conditional expression. This is the gate to the conditional block. So if this condition is true, then we execute the body inside the block. And then we skip whatever else is outside of it. It's just gonna go straight to whatever's outside the conditional block. Otherwise, if it's false, we skip to what's inside the false block. So this is if, then do this, and then get out of the if block. Else, if this is false, else do this, and then get out of the else block. This is a side note. There can never be an else branch without an if branch before it. The if-else construction as a whole forms a single conditional statement, right? So you can't just have else. You can have number, integer, input, please type in a number, and then print the number is negative without just have printing this without it being changed to get chained together here. So this and this go together. You can't have this without the if statement here preceding it. The following example checks whether a number given by the user is even or not. Parity can be checked with the modulo operator, percentage, the percentage sign, which produces the remainder of an integer division operation. When divided by 2, if the remainder is 0, the number is even. Otherwise, the number is odd. So again, we have a variable called number. It stores an integer value. And here we check if number divided by 2 equals 0. So basically saying if the remainder of whatever our number is divided by 2 is 0, then we want to print that the number is even. Otherwise, we want to print that the number is odd. So this is how the program will look. If we plug in the number 5, it's going to say the number is odd because 5 divided by 2 does return a remainder. It will return 1, which means it's an odd number. So the number is odd. Another example with string comparison. So here we have a variable called correct. It stores a string called kitty cat, not called, but the string kitty cat. Then we have a password variable, which stores the user inputted string. And then we check if password is equal to correct. In other words, saying if password, whatever we input here, is equal to kitty cat, then print welcome. Otherwise, print no admittance. And this is in very, 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 very simple ways is how, user authentication and registration forms work. We have a piece of information stored in a database, and then when I'm trying to log in, our program, our server, or our backend will compare what I input to what it can see on the database. And if those things match up, then it lets you proceed further into the web app or the mobile app or whatever. So with 2 different inputs, this should be printed out. If we input kitty cat, then it says welcome. If we input monkey, then it says no admittance. Okay, now we have our first exercise here called age of maturity. It says, please write a program which asks the user for their age. The program should then print out a message based on whether the user is of age or not, using 18 as the age of maturity. Some examples of expected behavior. So ask us how old you are. We put in 12. It says you are not of age. How old you are? 32. It says you are of age. So we know that we need a variable to track age, which is going to store an integer signifying the user's age. And then we do if age is greater than or equal to 18, then print you are of age. Then we're going to say else, print you are not of age. We can also do if age is less than 18, then it's going to do you are not of age, otherwise print you are of age. So here if we test this, I actually meant to do if we run this and plug in the values ourselves. So if we plug in 12, it says you are not of age. If I plug in 32, it says you are of age. Right, so again, if we test this, we should see that it works. And we can also view the model solution. And same thing. So it asks, see, this one checked if you're just below the age of 18, when in our solution, we asked if we're older than or equal to 18. So both of these work. So if you're below the age of 18, it prints you are not of age. And if you're anything other than, if you're 18 and above, it says you are of age. Okay. Alternative branches using the elif statement. Often there are more than two options the program should account for. For example, the result of a football match could go three ways. The home team wins, the away team wins, or there is a tie. A conditional statement can be added to with an elif branch. It is short for the words else if, which I briefly talked about earlier when I was comparing Python to the other languages that I'm familiar with, and maybe some other people watching these videos are familiar with as well. In Java, JavaScript, TypeScript, C++, we use if and else, but in Python they use the kind of shorthand written way of elif, which means the branch will contain an alternative to the original condition. Importantly, an elif statement is executed only if none of the preceding branches is executed. So here we have a conditional statement flow again. So we have the first conditional expression. If this is true, then do what's inside the gate, what's inside the conditional block, and once that's done, come all the way outside the block and continue with the rest of the code. But if this is false, then we go to the second conditional expression. This will be the elif. So we check this now. If this is true, we do what's inside the elif block. If it's false, we go down here, which will be the else statement, and then we continue to execute outside of this else if block. So let's have a look at a program which determines the winner of a match. We have a variable here called goals home, which stores an integer value of the goals scored by the home team, then goals away, which stores an integer value of the goals scored by the away team, and then we check if the home team scores more than the away team, then print the home team won. Else if the away team scores more goals than the home team, then print that the away team won. Otherwise, print it's a tie. So when I'm reading this, I'm gonna try to read it in natural language, so you can it'll be a little bit easier for you to interpret what the code is saying. The code is saying if the home team has more goals than the away team, then print the home team won. Otherwise, if the away team scores more goals than the home team, print that the away team won. And if both of these are not true, then it must mean that both teams tied, so print it's a tie. So this is how the program will print out with different scores. So the home team scored 4 goals, the away team scored 2 goals, then the home team won. The home team scored 0 goals, the away team scored 6 goals, then that means that the away team won, or print that the away team won, and then here both teams tied, so it prints that it's a tie. In the above example, there are 3 alternative branches, exactly one of which will always be executed. However, there is no limit to the number of elif branches a conditional statement can contain, and the else branch is not mandatory. So this is also a valid conditional statement. So here we are printing the holiday calendar. We're storing the date in this variable called date. Stores the input string from the user. Then we see if the date is equal to December 26th, print it's Boxing Day. Else if the date is December 31st, print it's Hogmanay. Else if the date is January 1st, it's the New Year's Day. So you can chain as many else ifs as you want, and you can go on forever as long as the first line preceding the else if condition is the if statement. So it has to be preceded by an if statement and its body, and then you can chain as many else if and their bodies as much as you want. You also don't need an else statement at the end after the final else if. That's totally optional. So here we say we print holiday calendar, and then it asks what is the date today. We write in December 31st, and it prints it's Hogmanay, and then thanks and bye. Notice the previous example has no else branch. If the user inputs a date which is not mentioned in any of the if or elif branches, or inputs a date in a different format, none of the 3 branches of the conditional statement is executed. So we can type in any other date that we want here. It's not gonna execute any of these because that condition will be met. If we put in December 25th, well, it's not December 26th, it's not December 31st, it's not January 1st either, so all of these will be skipped. It's just gonna go here. Okay, is December 25th the same as December 26th? Nope. Okay, is it the same as December 31st? Nope. Is it the same as January 1st? Nope. So we don't execute anything in here, and we just go ahead and print thanks and bye. We've seen this in one of the exercises in the previous chapter, where we were asked to write a program that accepts a year, and if the year equals 1984, then we print Orwell. And if it's any other year, don't do anything. So that's essentially what we're doing here. So here, it prints holiday calendar, and then it asks us what the day is. We put in December 25th, and then it just goes straight to saying thanks and bye. So if you remember that Orwell exercise, it asks us enter a year, we enter 1984, then it prints Orwell. If we enter 1982, it just goes to thanks and bye. Okay, we have another exercise here called greater than or equal to. Please write a program which asks for two integer numbers. The program should then print out whichever is greater. If the numbers are equal, the program should print a different message. Some examples of the expected behavior. Please type in the first number, we plug in 5. Please type in another number, we plug in 3. The greater number was 5. Then it says here, please type in the first number, 5. Please type in another number, 8. Then the greater number was 8. Please type in the first number, 5. Please type in another number, 5. The numbers are equal. So we know we're going to have two variables, number 1 and number 2. And both of these are just going to be integers. Input, please type in the first number. And what you just saw me writing on two lines at the same time, if you hold Alt, click on the line that you want to type on, and click on the other line, while holding Alt, it will put two cursors on the document. So you can type in, if you're writing the exact same thing on both lines, you can do it that way. So that's another shortcut and cheat that you've learned today. And so now here we're going to have conditionals. We're going to say if number 1 is greater than number 2, then print the greater number was number 1. Then we're going to say elif number 2 is greater than number 1. Actually, this needs to be a 2 here. Then we say print the greater number was number 2. And then else print the numbers are equal. So let's run a test here. 5 and 3. Oh, pardon me. It's supposed to be 5 and 3. And we have a typo somewhere. Okay, the greater number was 5, which matches here. If we plug in 5 and 8, the greater number was 8. And if we plug in 3 and 3, we get the numbers are equal. We have a typo here. So this and here. Okay, and that's it. So if we run our test here, we should be good. And we are. We can also look at the model solution. And same thing, if number 1 is greater than number 2, print the greater number was blank. Else if number 2 is greater than number 1, print the greater number was number 2. And then otherwise if the numbers are equal. Okay, we have another exercise here called the elder. It says, please write a program which asks for the names and ages of two persons. The program should then print out the name of the elder. Some examples of expected behavior. Person 1, name Alan, age 26. Person 2, name Ada, age 27. The elder is Ada. All right, so Bill and Jean are the same age. Okay, so we know we're going to have to first print person 1. And we're also going to need to print person 2. Then here we're going to have a variable called person 1, which equals to an input. And then here we're going to have, and we're also going to have age 1, which equals to integer input age. So I'm just going to copy this to paste them down here. Change person 1 and age 1 to person 2 and age 2. And then we do if age 1 is greater than age 2, then we want to print the elder is person 1. Then here elif age 2 is greater than age 1, then we want to print the elder is person 2. And then else print, we can do it this way, with an F string, person 1 and person 2 are the same age. So let's run this, see what we get. If we plug in Alan and Ada, so 26 and 27. So Alan is 26, Ada is 27. The elder is Ada. Okay, and if we type in Bill and Jean, 1 and 1, Bill, Jean, oh, I'm sorry. Bill is 1 year old, Jean is also 1 year old. Bill and Jean are the same age. Let's run our test. Awesome. We can also view the model solution for our curiosity and see. Same thing, name 1, age 1, name 2, age 2, and same thing. Check if age 1 is greater than age 2, print name 1. If age 2 is greater than age 1, print name 2. Otherwise, they're the same age. All right, we have here another exercise, which I think it is the last exercise, called alphabetically last. We're told that Python comparison operators can also be used on strings. String A is smaller than string B if it comes alphabetically before B. Notice, however, that the comparison is only reliable if the characters compared are of the same case. Both are uppercase or both are lowercase, and only the standard English alphabet of A to Z or A to Z, lowercase A to Z and capital case A to Z is used. Uppercase. Please write a program which asks the user for 2 words. The program should then print out whichever of the 2 comes alphabetically last. You can assume all words will be typed in lowercase entirely, so we don't have to worry about converting casing in the inputted word. Some examples of expected behavior says please type in the first word, car, please type in the second word, scooter. Scooter comes alphabetically last. Please type in the first word, Zorro. Please type in the second word, Batman. Zorro comes alphabetically last. Please type in the first word, Python. Please type in the second word, Python. You gave the same word twice. Okay, so we need 2 variables here, word 1 and word 2. Now, equals to an input. Please type in the first word. And here we're going to type in the second word. And then we're just going to do if word 1 is greater than word 2, then print we should do F string here, that word would be word 2, right? Comes alphabetically last. And then, so let's test this, just with this. So here if we write car and scooter, so actually we should do it this way then. Car, scooter, then scooter comes alphabetically last. And then if we do elif, word 1 is greater than word 2, then print word 1 comes alphabetically last. And then else print, pardon me. Oh, actually, no, that's, yeah, it should work. You gave the same word twice. So here if we do Zorro and Batman, Zorro comes alphabetically last. And then if we do Python and Python, you gave the same word twice. Let's run our test. And we passed. Check the model solution, and the same thing. So they did it, they put this one first, well, we put it second here. So word 1 is greater than word 2, then word 1 comes out, because it's a kind of wonky way to think about this, because it's judging the first letter. So if the first letter is closer to the start of the alphabet, then that means that it's smaller than this letter. if that makes sense. So when we do word 1 is greater than word 2, then that's false because word 1 will be a lower number than word 2. I don't know if that makes any sense. It's a little wonky to think about it. That's why I put this one first and this one second. But yeah, so if word 1 is basically closer to the start of the alphabet, then that means that word 2 is further towards the end of the alphabet. This is what I was thinking about when I was writing this. Same thing here. If word 1 shows up later in the alphabet, then that means that it's larger than word 2. This is such a, it's an annoying way to think about it, but it makes sense when I'm writing this. I hope you guys can see that, right? So let's do this. If we have an alphabet, A, B, C, D, E, F, blah, 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 and we're comparing words that start with the letter F and a word that starts with the letter C. So what we're saying is if word 1 starts with the letter C and word 2 starts with the letter F, then that means that the word that starts with the letter F comes alphabetically last, right? It comes further towards the end of the alphabet than the words that start with the letter C. And on the other side here, we have a word that starts with the letter F again and a word that starts with the letter D again. And again, same thing. If that word that starts with the letter F is further along towards the end of the alphabet, so it's technically, quote unquote, a larger value. This will be a lot easier to think about if you looked at it on the ASCII key. Let's see if we can find it. ASCII alphabet, I think it was. Yeah. So each letter is assigned a numerical value on the ASCII table. So if you see here, this is probably an easier way to look at it. Let's go to just an example. So let's say, for example, A is 1, B is 2, C is 3. So if we're comparing F to A, that means F is greater than A, which means F shows up towards more towards the end of the alphabet. Hopefully a visual like this helps. I know this is even more wonky to look at, but this is sort of like the mental that I have in my mind. But just imagine that we're grading each word, or we're assigning a numerical value to each word that starts, depending on what letter it starts with. So the word like apple, for example, will have a value of 1, while a word that starts with F, like fox, has a numerical value of 6. 6 is larger than 1, meaning that fox shows up later in the alphabet than apple does because it's a larger number. Hopefully that makes some sense. I'll put a link in the description of this picture if you want to look at it, or something a little bit more clearer, but that's what I'm thinking in my mind when I'm doing this exercise. But that's about it. So this is the final exercise in section 2. We're brisking through these. Again, the goal of these videos is to stay within 30 minutes or so and do the exercises. The previous chapter, we got lucky where the course material, basically the readings, all preceded the 3 exercises. In this one, we have a little bit of readings, followed by an exercise, followed by another bit of a reading, followed by the remaining exercises. But all the solutions are in this video for these exercises. So make sure you watch the video. These solutions will also be uploaded to the GitHub repository. Again, link is in the description below. If you've enjoyed this video, if you've gotten some value from it, please give it a thumbs up. If you have any questions, please make sure to leave them in the comments below. I will respond. No questions asked. If you need any more resources, if the material is a little bit more challenging, I will, answer to the best of my abilities. So thank you so much for tuning in, and I'll see you guys in the next video.